Welcome to the DIY Honda Garage channel. This presentation focuses on the Diagnostic Trouble Code, DTC P1077, which indicates that the Intake Manifold Tuning, IMT valve, is stuck in the high RPM position for the Honda Civic models ranging from 2006 to 2011. The IMT valve plays a critical role in optimizing engine performance by adjusting the airflow into the intake manifold, which in turn improves combustion efficiency at varying engine speeds. When the valve is stuck, the engine may not perform optimally, leading to issues with power delivery, fuel efficiency, and emissions compliance. The location of the IMT actuator is typically found within the intake manifold assembly, and it is connected to the Engine Control Module, ECM, or Powertrain Control Module, PCM, for receiving signals regarding its operational status. Before initiating the troubleshooting process, it is imperative to record all freeze data and any onboard snapshots to better understand the conditions under which the fault occurred, as this information provides crucial context for the diagnostic process. The DTC P1077 signifies that the IMT valve is stuck in the high RPM position. The IMT valve modifies airflow through the intake manifold to enhance engine performance and efficiency. Its improper functioning can detrimentally affect power output and fuel consumption. The IMT actuator, which controls this valve, is generally located in the intake manifold assembly, directly affecting the engine's air intake process. This actuator communicates vital information to the ECM, which processes the data to ensure that the vehicle operates smoothly across different RPM ranges. If the IMT valve is stuck, it can lead to performance degradation, contributing to issues like loss of acceleration and increased emissions. Understanding how this component functions and its interaction with the ECM is key when addressing this DTC. Multiple factors can lead to the occurrence of DTC P1077. An intermittent failure indicates that the system may sometimes function correctly, but fails under specific conditions. This variability is important to investigate further, as it could involve poor connections or loose terminals at the IMT actuator or the ECM PCM. Such issues could prevent the actuator from receiving or sending proper signals. In addition, a faulty IMT actuator could be the root cause, failing to adjust the valve position as required by engine performance needs. Each of these potential causes highlights the importance of thorough inspections and tests to isolate the exact fault, preventing the proper functioning of the IMT system. Troubleshooting should focus initially on recording data and examining electrical connections to rule out these common issues. Several symptoms may manifest when encountering DTC P1077. A prominent sign is poor acceleration, where the vehicle may struggle to gain speed, indicating that the IMT valve is not functioning optimally to regulate airflow. Increased emissions may also be noted, resulting from inefficient combustion due to improper air-fuel mixing. Drivers may also experience rough idling, which can feel like fluctuations in engine RPM at a standstill. Other potential symptoms include decreased fuel efficiency and diminished engine performance under load. By carefully monitoring these symptoms, technicians can gather valuable insights into the underlying issues affecting the IMT system and assess whether they correlate with the DTC being reviewed. Recognizing these symptoms early on can lead to more informed and effective troubleshooting actions. The first step in troubleshooting DTC P1077 involves turning the ignition switch to the on position. This action supplies power to the vehicle's systems without starting the engine, allowing for diagnostics. After powering up, use the Honda Diagnostic System, HDS, to clear the DTC. Clearing the DTC is essential because it resets the system, allowing you to determine if the issue is intermittent or consistently present. Following this, perform the IMT test available in the inspection menu of the HDS. This test evaluates the operational status of the IMT actuator and valve under controlled conditions. The results will guide the subsequent steps. A positive outcome suggests that the system is functional currently, but further investigation of connections may be warranted to identify intermittent failures. After completing the IMT test, evaluate the results. If the outcome is satisfactory, this could indicate an intermittent failure, meaning that the system works correctly at that moment but could fail again later. In such cases, it's crucial to inspect for poor electrical connections or loose terminals both at the IMT actuator and the ECM/PCM. If left unaddressed, these connection issues could allow for inconsistencies in the signals sent between components, leading to performance problems. Ensuring these connections are secure can often solve intermittent issues without replacing any parts. This step emphasizes the importance of thorough inspections, as many problems stem from simple connectivity issues rather than component failures. For the next troubleshooting step, first turn the ignition switch to the lock 0 position. This action safely powers down the vehicle's electrical system before performing further diagnostics. Next, disconnect the IMT actuator's 5P connector, which is essential for isolating the actuator from the rest of the system. This step ensures that any testing done next refers only to the actuator itself, without influence from other components. Following this, turn the ignition switch back to on in 2 to power the electrical systems again. This step prepares the setup for measuring voltage at the actuator's connector, which will assist in determining whether the actuator is functional or if further issues exist with the electrical supply. In this troubleshooting step, the goal is to measure the voltage between terminal number 1 of the IMT actuator 5P connector and body ground. This measurement will help assess whether the electrical supply to the actuator is functioning within specifications. The expected voltage should be approximately 5 volts, indicating that power is reaching the actuator correctly. If the voltage is present, a positive reading suggests that the actuator may be functional, guiding the technician to the next steps in troubleshooting. Conversely, if the voltage is not present or is significantly lower, it may signal an issue with wiring or electronic control that requires further diagnosis. This step is key to isolating electrical issues from mechanical concerns. To proceed with the next step, again ensure the ignition switch is turned to the lock 0 position. This action guarantees that the vehicle's electrical systems are powered down during the next procedures. The next task involves jumping the SCS, service check signal line, using the HDS. This step is necessary to bypass the safety feature that may inhibit diagnostic testing. After preparing the system, disconnect the ECM/PCM connector B, which is critical as it interfaces directly with the IMT actuator. This disconnection allows for further testing of the wiring and ensures that any faults detected are not influenced by the ECM's control signals. Proper handling and identification of these connectors are vital for effective troubleshooting later on. The final step in this specific process is to check for continuity between terminal number 1 of the IMT actuator 5P connector and terminal B18 of the ECM/PCM connector. Continuity indicates that the electrical connection is intact, allowing signals to pass between the actuator and the ECM. Use a multimeter set to measure continuity for this check. If continuity is present, this suggests that there are no breaks in the wiring, which indicates the IMT actuator may be faulty and requires replacement. However, if there is no continuity, it signals an open circuit in the wiring that must be repaired to restore functionality. Thorough checks of these connections are paramount, as they can often be the cause of IMT-related issues. Following the completion of any repairs, it's crucial to carry out a final verification test to ensure that the vehicle is functioning normally. Begin with a test drive under various conditions, allowing for observation of performance across different RPMs. During this drive, monitor for any symptoms associated with DTC P1077 and check for the recurrence of the error. If the DTC does not reappear and the vehicle operates smoothly, this confirms the effectiveness of the repairs made. However, if symptoms persist or the DTC returns, additional diagnostics may be required to ensure full resolution of the issue. This verification process validates the integrity of the repair work and the overall functionality of the vehicle's systems. Preventive maintenance is crucial in avoiding future occurrences of DTC P1077. Regular inspections of the intake manifold and the IMT system should be performed, focusing on ensuring that connections remain secure and free from corrosion. It is advisable to periodically check the integrity of connectors, as loose or damaged connectors can lead to intermittent failures. Additionally, monitoring engine performance and fuel efficiency can provide early warnings of impending issues. For example, a sudden drop in fuel efficiency may indicate that the IMT valve is becoming compromised. As a general practice, keeping an eye on DTCs logged in the system can also allow for timely interventions, preventing more significant issues down the road. Ensuring these elements are in place helps maintain optimal vehicle performance. In summary, DTC P1077 is centered around the IMT valve being stuck in the high RPM position, with various causes and symptoms that can affect vehicle performance. Understanding the roles of the IMT actuator and its connection to the ECM is vital for effective troubleshooting. The diagnostic steps outlined provide a structured process for identifying the root cause, from initial testing through to final verification. Regular preventive maintenance and inspections can significantly mitigate risks of future DTCs, ensuring the longevity and reliability of the vehicle. Adequate checks on connectors and monitoring performance can act as early warning signs of potential issues. Ultimately, proper diagnosis and timely repairs lead to a smoother running vehicle and enhanced driver satisfaction. Please like and subscribe to the channel. See you next time.